Hi Honors Math 9. Today's lesson is 6.3, Solving Systems of Nonlinear Equations and Word Problems. Our first word problem is a break-even point. A fashion designer makes and sells hats. The material for each hat costs $5.50. The hat sells for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? So in order to do that, we need to come up with a cost function and a profit. So we know that it cost $5.50 per hat. So since it's the per, that is going to be our slope. And then they spent $1,400 on advertising, so plus $1,400. Since the hat sells for $12.50 each, we're taking a profit. Actually, scratch that. Revenue is the income of $12.50 per hat. So if we're going to find the break-even point, when the breaking even means you're going to come out not making money, not losing money, so they're going to be equal. So what we're going to do is when the cost equals the revenue, so we're going to set them equal to each other. 5.5 each plus 1,400 is equal to 12.5 each. I'm going to solve for each, so I have 1,400 is equal to 7 each, and H is equal to 200. So they must sell 200 hats to sell to break even. All right, another equilibrium problem. The local zoo is filling 2 water tanks for the elephant exhibit. One tank contains 50 gallons of water, filled at a constant rate of 3 gallons per hour. The second tank contains 29 gallons of water and is filled at a constant rate of 10 gallons per hour. When will the 2 tanks have the same amount of water? So we're going to create some equations. So I'm going to come up with the equation for tank number 1. We know tank number 1 has already 50 gallons in it, plus the rate of it is 3 gallons per hour. So again, I'm going to use H. Tank number 2 starts off with 29 gallons, and that rate is 10 gallons per hour. So again, if we're finding equilibrium, we're going to figure out when T1 is equal to T2. So we're going to set both of those equations equal to each other. So we have 50 plus 3H is equal to 29 plus 10H. I'm going to bring the constants to this side, so I'm going to subtract 29 from this side. I'm going to subtract 3H from this side. So we're going to have 21 is equal to 7H. So H is equal to 3. So after 3 hours, the tanks will be the same. Example is to solve by graphing. We have this system, y equals 3 to the power of x, which is an exponential function, and y equals 6x minus 3. If you don't have a graphing calculator, I would suggest you to use Desmos. Remember, we used Desmos before when we were solving linear equations. If not, it's the same thing as our graphing calculator where you're going to do the second trace and do the intersect. So the first one, I'm going to type y equals 3 to the power of x. In order to get to the power, you're going to do the power of 6 and shift that up to the power of x and hit enter. Your graph should show up on the graph. My next one, I'm going to do y equals 6x minus 3, hit enter, and then we have our graphs done. If you double click on it, you'll be able to see the intersection points. It has them highlighted in gray, and if you click on them, they'll turn black. They are the coordinate points 1, 3 and 2, 9. So unlike systems of linear equations where we only had one answer, sometimes you might have 2 exact answers. Our next example, we're going to first solve by substitution and then check our work by graphing. So substitution is when you take a letter by itself and then you're going to substitute it back in. So since y is equal to 5x minus 10 here, I'm going to take y out of this equation and plug that in. So now we have the equation 5x minus 10 is equal to x squared plus 2x minus 8. Remember, whenever you solve a quadratic, meaning anything to the power of 2, you have to set your equation equal to 0. So I'm going to subtract 5x from both sides, and then I'm going to add 10 to both. So I have 0 is equal to x squared minus 3x plus 2. And now we can solve this quadratic by one of three ways: factoring, quadratic formula, or completing the square. I personally like to check to see if it factors. What multiplies to 2 and add up to negative 3? We have negative 2 and negative 1. So 0 is equal to x minus 2, x minus 1. Solving, so each of them factors equal to 0, x is equal to 2, and x is equal to 1. And remember, you always have to solve, these are solutions would be coordinate points, so you have to plug them back into either one of the equations. I'm going to do the bottom equation because it's a little bit simpler. Y is equal to 5 times 2 minus 10, which is 0, and y is equal to 5 times 1 minus 10, which is negative 5. So that means our solution is the coordinate point 2, 0, and 1, negative 5. We're going to do it by graphing, so I'm going to enter the two equations. Y equals x to the power of 2, make sure you jump back down, plus 2x minus 8. And Desmos graphed it for us. I'm going to hit enter to come up with the next equation, y equals 5x minus 10. And then by looking at the graph, you can either zoom in or zoom out by using these plus or minus. So zooming out or zooming in. I'm going to looking at the graph, you can see that a gray dot showed up, so there's the point 2, 0. And click and slide, and you'll be able to see down here at negative 5, another gray dot shows up, and then that's the other intersection point. Good, so this time we have two intersection points again. All right, so again, we're going to solve the system by substitution. So y equals, we're going to set them both equal to each other. So we have x squared plus 4x minus 12 is equal to negative x squared plus 4x minus 4. Again, whenever you solve a quadratic or a quadratic equation, you always have to set the equation equal to 0. So I'm going to bring everything to one side. So I'm going to add x squared to both sides. I'm going to subtract 4x from both sides. I'm going to add 4 to both sides. Since both of these numbers are divisible by 2, I'm going to divide both sides by 2, and I'm left with x squared minus 4 is equal to 0. I notice that this is the difference of perfect squares, so this factors to x plus 2. X minus 2 is equal to 0. So x is equal to negative 2, and x is equal to a positive 2. So again, those are the x values, so you have to plug them in for x into either one of those equations to solve for y. Y is equal to, again, whenever you do substitution, put parentheses around it. I'm going to do this for both numbers, 2 and negative 2. And when you plug in the 2, you should get 0. And when you plug in, when you plug in negative 2, you should get negative 16. My apologies. And when you plug in a positive 2, you should get 0. So your solution is the coordinate point 2, 0, negative 2, negative 16. Again, we're going to solve this system by graphing. So y equals x to the power of 2 plus 4x minus 12. And again, Desmos graphed that one for us. And my other one, y equals negative x to the power of 2. Jump it down, plus 4x minus 4. And this time for my graphs, I don't see the whole big picture, so I'm going to zoom out a little bit. And there we go. Can see here this gray dot, 2, 0. And this other gray dot, negative 2, negative 16 for both of the solutions.